All right, so I'm going to try and tell you in about 15 or 20 minutes everything you need to know for the Type II certification for the EPA. So we're going to say that this is your HVAC GPT for Type II, and you're given a scratch piece of paper to write everything down on before you take the exam. So you can dump a bunch of stuff out on the piece of paper before you start going. And the thing about the Type II, most people get confused, is there's three classification of systems. There's comfort systems that are for people, whether it's in an office building or a school or whether it's a house, it doesn't matter. It's comfort is our one type of system compared to another, which is commercial refrigeration. That would be more for like at the supermarket, you have all these dairy and display cases. There's a rack system somewhere on site that all those feed back to. That's commercial refrigeration. Or if you think about a warehouse that holds flowers or stores cold storage for something, that's going to be commercial refrigeration as well. And then the last one is the industrial process refrigeration. They used to just call it industrial, but the industrial process refrigeration is more for manufacturing techniques. If you're doing microchips and there's something in the manufacturing that's got to be cooled by a big system, that's going to be the industrial process. Or if there's like steel rolling mills that are rolling sheets of steel that are molten lava that need to be cooled prior to going through some of the mechanical processes, that's also going to be industrial process refrigeration too. So that's the three classifications, and the reason you need to know them is they're broken down into this 10% for comfort, and commercial refrigeration is 20%, and 30% is our leak repair requirements for these three classifications. So it depends on whatever they fall in. So if you had a system that was 65% industrial process refrigeration and they ran some water off of it to maybe work some fan coil units for the other 45% of coolant or 35% of coolant, if it's 65% over here, then that's going to be a primary instead of comfort system, industrial process system, and it'll fall under these leak repair requirements if they're drawn from the same. You go with the majority of the system that you're there. And then the system's going to have a pre-charged amount from the factory. So the system charge, okay, is going to be determined usually by the nameplate. And you don't have just the nameplate. If it's a really long refrigerant run or opposite, really short refrigerant run, you might have a line set charge, all right, that could have to maybe add, if you had a long line set run of 100 feet, on top of the factory charge, which is what's going to be on the nameplate. So the factory charge is on the nameplate, and then you might need to add that to find out if you're adding a certain amount of refrigerant, what your leak calculation is. So you got, maybe a little bit of math to do if it's not using just, the 20 foot of standard line set or 15 that the factory comes with. For your leak repair requirements on that. So it's going to be the total charge, and you might need to figure that out, usually with whatever's written on the nameplate. Plus there's math that the manufacturer has for their in their installation manuals that technicians use to add the proper amount of charge to that if they're not using superheat subcooling. Most of the time we're weighing in the exact amount, so that's going to determine whether the total amount that you're leaking for the 1 year or not. And these leak repair requirements really only count if you are over, if that system has more than 50 pounds of any of the high pressure, medium pressure refrigerants. So if it does not, if it only has 5 to 50 pounds, then you just need to keep records. So the records need to be kept for 3 years, okay? And that's only if it's got 5 to 50 pounds or if it's got any of these leaks here. So, and then one of them, if you are exceeding 125% of the total charge, then you've got to report that to the EPA, okay? And that's going to be one of the new requirements there that they're looking for. So the other thing is that if you have more than 200 pounds of refrigerant, then you're going to have to get this leak tested and a follow-up verification test within 10 days. So equipment owner, okay, if they have over 50 pounds, has got 30 days to repair that leak, and then the 10 days is the verification test to make sure we're not leaking more than 10% of 50 pounds over a calendar year. Now, if the system's like a commercial system, a very large system, let's say it's got 1,000 pounds of refrigerant in it, and it leaks out 200 pounds of refrigerant, and it's a commercial system, okay, then you're gonna have to get that leak fixed and get it repaired if it exceeds any more. Let's say you go out and you put 200 pounds of refrigerant in there, and 3 months from now they need more refrigerant. Any more refrigerant is going to require a leak check, and then after you fix the leak, a verification to make sure that the leak's repaired. But if it doesn't, let's say that you put in less than 200 pounds of refrigerant within a calendar year, then there's no requirement by the EPA if it's a commercial refrigeration unit to fix the leak at this time. So, and the same for the 5 to 50 pounds, but you probably should do so whenever for environmentally good reasons. So, the other things you probably should know is that if you do have a unit that does have, let's say, maybe 400 pounds of refrigerant leaking out of it, that's 40%, and it's industrial process or any of these other, you are going to maybe try and think about replacing the unit. They have this thing in the test they call mothballing the unit maybe. Let's say you have a backup unit, then you can do this thing called mothballing, but you've got to isolate the section of the unit that has the leak and remove any refrigerant, and that's one of the requirements. And then you can stop the clock. That's one of the requirements, to stop the clock if you want to extend time on that repair. If the facility is a commercial facility and it's a big piece of equipment and it's using maybe R22 refrigerant for some sort of flowers or something like that. So, but most of the time you got like a 30-day window to make a retrofit plan if they're not going to take it and mothball the system and put it in storage. So, and then that's it. So, but let's take a look at the system. I like to draw a few systems for the students. And let's say you got a condensing unit here, right? And it fed from a compressor over here. You got your compressor, and then it feeds into, let's say, sometimes they feed into a receiver tank for these bigger systems, and there's a dip tube, and the receiver tank feeds down to over to a meter and vise, some sort of expansion valve, before it goes in the evaporator, before it's fed back to the compressor. Okay, so that's your AC system there. And generally, when we're doing this type of work with a system, we want to make sure that the system doesn't have any leaks with traces of oil. We can do a visual inspection. Let's say we see a dark spot on the condenser coil there of oil, then we could have a leak, and we would probably fix and find and repair that leak, and then do the verification that there's no further leaks. And that verification could be a standing pressure test, where you're just taking your tank of nitrogen, which you already had if you did the leak repair, flowing through the system anyway. So you connect that up to your valve here, and then blow it through while you're doing your braze. And then let's say we want to verify that you got a leak. So you got your low pressure gauge here hooked up, and the low pressure gauge, is at 0, and then you're going to pressurize it to the test pressure of whatever the nameplate said. So the nameplate will tell you what the factory charge is, and then somewhere there's usually a high and a low that tells you also the refrigerant type and the amount of test pressure on the high side and the low side for the refrigerant type. So if you got a 150 low side test pressure maximum and a 450 high side test pressure maximum, and you haven't isolated any of the system, everything's open and connected and cycle, you have to go with the lower of the two pressures, and that's the maximum that you would want to put nitrogen test pressure through the regulator. So the regulator would be installed, and you would also make sure that you can't put 2 or more regulators in series. There's a flow guard a flow amount that we put in, a flow meter for the brazing while we're putting in for purging and brazing. But other than that, there's only one regulator, and if it's got a pressure relief valve, those aren't installed in series, and they have corrosion. We replace those pressure relief valves on those regulators for those nitrogen tanks. But whatever the 150 is, let's say you push this up to 150 psi and the needle drops down, that means you still have a leak. The verification test failed, and let's say you can't find it, you can't hear it, you don't see a trace of oil. Then you might want to add a little bit of trace gas. Back at the nameplate tells you whatever refrigerant it is. Let's say it's R22. That's what you put as a tank for about 10 psi of trace gas before you put the 150 psi of nitrogen pressure behind it to raise it up to a test pressure range. And then you can just vent that out into the atmosphere. You don't have to worry about doing anything with this here if it's got a little bit of trace gas in it. You cannot, though, put a nitrogen tank to a fully charged system and hook that up and put nitrogen in with that full charged system and vent it out. That's illegal. That's going to get you the $44,000 fine and somebody maybe a $10,000 reward for that there. So the other thing that you want to think about, that if you got 50 to 500 pounds of refrigerant, right? That's going to be every year that they've got to look to see that we're maintaining this leak rate. So after they find, fix, and repair the leak, they found the standing pressure test, and we pull a vacuum now. We switch our recovery tank, not our recovery tank, but our nitrogen tank to a vacuum pump, and we pull down to 500 microns, okay? We get down to that 500 micron level, and it shows that we've dehydrated the system and removed all the moisture. Then we can push refrigerant back into the system. Now, if this is on a chiller barrel, this evaporator, we have to charge our 400 series refrigerants. Let's say the refrigerant charge was R410A. Well, you're going to want to get the pressure of R410A up to 110 psi so that it can equal 36 degrees saturation temperature. That's the boiling point of that refrigerant. So it's not going to be liquid at 110 psi slamming up against the liquid water if this is a water barrel with the liquid refrigerant flowing through it. That could kind of make the water freeze, cause the tubes freeze and then expand and crack tubes, and we have another problem. So sometimes we put a little bit of vapor pressure in up to the saturation temperature of the refrigerant, freezing, so we get it above 32 degrees, and that will be then followed up with the liquid, because normally with any 400 series refrigerant we're charging and throttling it through the suction side as a liquid, but we would go ahead and start that off with any of the refrigerants that needed to be added as a liquid. If this was a water-cooled chiller barrel, that would be for a very large one of these types of systems. So other than that, once we get the vacuum down to 500 microns and you break the vapor with a little bit and add the liquid, then we're going to go ahead, and if you come back within a year and it's missing any more than 20%, it looks like there's a leak rate for the year, you're going to have to do another leak rate test, and that verification's got to be done within a 10-day period for the most part. So again, if it's got more than 500 pounds of refrigerant, then you're going to have to do that every 3 months. You're going to have a leak verification test done instead of every year on these 2 or 50 or 500 pound and less to 50. You got over 500 pounds of refrigerant. It's a lot of refrigerant being leaked out at 30%. So if we got a 1,000-pound system, you're leaking out 300 pounds. That's a lot of refrigerant to, if you dump and then come back in a month or two, to have to add another 300 pounds of refrigerant. That's a no-go. You're going to have to verification test a leak fix and make sure that you have that documented, because again, if you exceed 125%, that's going to get reported to the EPA. And all these things that you could do to leak test all this, it could be a electronic leak detector, it could be maybe a ultrasonic leak detector, it could be some sort of sniffer probe, it could be actually soap bubbles once you get the general area of a leak to pinpoint the leak, or if the leak's so small and you can't see it, then you gotta use maybe an injection dye system, a fluorescent dye system. So those are all the methods of leak detection. And then sometimes the rotating shaft seal, sometimes it's an open drive compressor that has a motor connected to it, and the shaft seal right here will also have traces of oil, and that, if it sits in mothballs for a long period of time, could cause that as well. And mothballing, again, is when they're isolating. Let's say we could pump down, we got a king valve here, and we don't need to hook up all the recovery machine, and we can pump all the refrigerant into the receiver, and then keep this with 0 psi, because this is in pump down mode, so we've isolated half the system. That's sort of a system dependent process for recovery, and that's going to be where you're not using the machine, the active process, or the you're using more of a passive process, and that would be okay. You'd stop the clock. That's what we were talking about initially when we started drawing this system. So a couple other techniques. If you have recovery happening and you need a receiver, let's say you're doing the leak repair, it's above the condenser, you're going to want to get it from the condenser outlet, any refrigerant, if all this is on the same level with that recovery machine. So you're going to hook a recovery machine up now. This is our recovery machine, and that's going to go to a tank of that's not mixed. Whatever the refrigerant's on the nameplate, that's the tank you should get. And that tank could be placed in a bucket of ice, and the ice will lower the pressure, lower the temperature, and make it easier for the recovery machine to pump the refrigerant in there. It'll speed the recovery process, and just a little recovery technique. The other technique that you could do is that if this is on it had the long refrigerant line set run, because it was maybe going from the first floor here, this condensing unit that you maybe pumped everything in the receiver, now has got a air conditioning evaporator that's on the 9th floor, up 9 stories. You're going to want to, or maybe the other way around, the condensers up on the roof and the evaporators down 9 stories. You're going to want to get from the liquid line, entering the evaporator right there, because all the refrigerant's going to be gravity moving, wanting to flow downward, and easier to go from the recovery machine into the tank. So there's a couple techniques that you can enhance your skills with on that. And all this is system dependent. You're going to need this recovery device and tank if it has more than 15 pounds of refrigerant. We can't use any passive processes if it has more than 15 pounds of refrigerant. So the other thing that you probably need to know is that there is if depending on whatever the nameplate says, a 410A refrigerant that's a high pressure refrigerant, or a low pressure or medium pressure refrigerant, lower than high. All right, so it could be like maybe 410A here, all right, high pressure R22, or it could be medium pressure like 134A, okay, and that's going to be your two types of refrigerant that determine the 0, 10, 10, 15, right? And that's going to determine then this way, between these two, if you have more than 200, so I'm going to say more, or we'll start off with less, all right, less than 200 pounds or more than 200 pounds. So if you have more than 200 pounds of refrigerant and it's a 410A or R22 unit, you have to get that needle on the compound gauge has got to get down to 10 inches in mercury before you open the system for service and repair. Now, if you have R134A refrigerant, and let's say it only has 50 pounds of refrigerant, then that's going to be less than 200 pounds, and that's going to mean that you need to also get down to 10 inches in mercury vacuum before you open the system for repair. And then if it has more than 200 pounds, all right, that's a big system, that's going to be 15 inches in mercury is going to be your way that you're going to want to get to the compound gauge down to before you open the system up for repair. So they might have a question where they're saying, hey, you got an R134A system, it has 300 pounds of refrigerant, what are you going to get your required vacuum rate down to according to the ARI? And that's what this is. This is the AHRI, now 740 standard, talking about your recovery equipment being able to get down to these levels before they can open the system for the purpose of service and repair. And that's one of the big things there that they're talking about with this chart of 0. If you remember 0, 10, 10, 15, and then just remember the top two are going to be the high pressure refrigerants, which you know 410A is high pressure, and then the ones on the bottom will be, you can use ESCO's PT chart if you're taking the ESCO certification exam, and they have on their PT chart that you use for the exam, it broken down to one side's all low medium pressure refrigerants and the other side's high pressure refrigerants. So depending on what side of the PT chart you're looking for will tell you what classification you're going to go into for the vacuum rates. And all you got to really remember is 0, 10, 10, 15, and then less than 200, more than 200, less than 200, more than 200. And high pressure is always more than medium or low pressure. So high pressure is above the medium pressure on this chart. And that's a way that you can deal with that. So a couple other things about this refrigeration cycle. You might have some accessories like a filter dryer. Filter dryer, anytime you open the unit for repair, it's got to be swapped out with a new filter dryer. We don't leave the old one in play. And then it also might have a sight glass moisture indicator on there that has a glass eye, sort of what the kids call. And that sight glass, if it freezes up, can be cleaned off with isopropyl alcohol. A couple of my students mentioned that they got that one wrong, and that's an easy one to get right. Just alcohol will take the frost right off, and that's what you should remove, not water, not definitely oil or any other chemicals that could be dangerous to it. So that's pretty much what I have for you guys for the study guide for this chart, for the what you could add for your study sheet. If you can get the system down and remember all that in these 10, 20, 30s, maybe that'll help you guys pass this test on the first try. And thank you very much for watching this. Appreciate it.